This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
Welcome to Software Engineering Radio. I'm your host, Gregory Kapfhammer. Today's guest is Marcelo Trylesinski, a senior software engineer at Pydantic. Along with working on data validation and cloud services at Pydantic, Marcelo is a maintainer of open source Python projects like Starlette and Uvicorn, both of which are frameworks that are leveraged by FastAPI that is the subject of our talk today. Marcelo, welcome to Software Engineering Radio.
Hey man, thank you very much. It's great to be here.
All right. Hey, I'm so glad you can join the conversation today. We're going to be talking about FastAPI. We're going to explore what FastAPI is, how Python programmers use it, and the specific problems that it solves. I think the first appropriate question is, from your vantage point, what is FastAPI?
FastAPI, it's a framework that's used to build APIs in Python. It leverages type hint, and it's very fun to develop with.
Okay, so you mentioned that it used something called type hints, or some people call those type annotations. Can you explain why that's one of the key features of FastAPI?
The thing that's cool is about the autocompletion. So it kind of forces you to use the right types, because you write on the signature of the function, you write the types that you're going to use, like the data you receive. So you have a data validation happening there. So the type that you put it there, it's for sure the right one.
So one of the things I know is that the word fast means more than one thing. So for example, the FastAPI website points out that it is fast from a high performance perspective, and that in a way it's also fast for me as a developer who's using FastAPI. Can you comment on why FastAPI is a web framework for building APIs that's fast in both of those fashions?
So for me, I always saw, even if I'm the maintainer of Uvicorn, the server that makes it one of the reasons that FastAPI to be fast. On my perspective, the fast is more about the user perspective. Because in any case, you're still working with Python and there are certain limitations. But the idea is that since you are leveraging the async IO world, you don't need to use the threads. So you can have more tasks running in a single thread. And then you have more capacity to run more tasks. And that means that you can receive and process more requests. And that makes the server faster, I would say.
So we'll talk a little bit later about the async approach that FastAPI takes. Before we dive into those technical details, can you share an example of a success story? Maybe like, for example, another open source project or a company that uses FastAPI?
I know a couple of companies that use FastAPI that are like big companies. Also, they are mentioned on the first page of the documentation, like as a testimonial or something, you know. I know that Netflix has one project that's open source as well. I think it's called Dispatch. If you look for Dispatch Netflix on GitHub, you're going to find it. I think that's the most famous one that's open source that is like really organized with several modules and stuff. So I would say this one. You also have, as an example of not a project that is running, but you have the full stack FastAPI that Sebastian, the creator of FastAPI, has just, I wouldn't say rebranded, but refactored. So it uses the latest technologies that he believes should be used with FastAPI. So those two projects, I think they're very nice. But yeah, I know also Microsoft uses it on some projects. I saw somewhere as well. But yeah, we use at Pydantic as well.
Thanks for sharing those examples. We'll link to some of those in the show notes for listeners who are interested in diving in and learning more. Now, you'll recall I mentioned a moment ago that FastAPI is for building these web APIs, and I'm aware of the fact that there are a whole bunch of different API standards, like the Open API standard or WSGI or ASGI. Can you help the listeners to understand what some of these various standards are and how FastAPI fits into this ecosystem?
Yeah, sure. So the Open API standard, it's for defining how your API looks like. So it works only with HTTP related methods. So you don't have, for example, event-driven events happening on the, like you cannot describe them on the Open API spec. So for example, FastAPI also supports WebSockets, but you cannot describe them on the OpenAPI because the standard, like the specification, does not tells you a way to specify how a WebSocket looks like. But you can specify all the HTTP methods like get, post, but So this is one thing. But what you mentioned about the UASCII and the ASCII, they are not related with this standard. They are more about how you build actually it's the interface, how you interface the server and the application. So UASCII was the Python standard for many years, and it's also there's a PEP about it, and there's also a package called UASCII on the standard library that you can use to test and create your UASCII applications. But the ASCII one, which is kind of, I'm not sure if it's considered new still, because by now it has 7 years, I think. It's from 2018 or 17. And it's just defined as an interface for you to write Python web frameworks, the server and the application, leveraging async Python. So UASCII without async, ASCII with async.
Thanks for that response. That was really helpful. Now, you mentioned that the A in ASCII or ASGI stands for asynchronous, and you mentioned async previously. Can you develop for the listeners a little bit more? What is the meaning of asynchronous, and why is that important in the context of using FastAPI?
If you look at how things happen sequentially, so the server gets a request, right? And then it needs to do something to send to the application. So in the UASCII world, not the ASCII, UASCII previously, you had to create a thread or use a thread if you had a thread pool, and then send, you process the request that you're receiving, like you get the data, and then you pass that data to the application via thread. On this new ASCII world, you'd create a task, a sync task, and then you'd pass it's the same process, but instead of using a thread, you're going to use a task, which for one reason, I'm not sure if it's easy to code with, but your application does run really fast when you have multiple of those running. You use far less resources.
Sure, that makes sense. So there's a clear benefit to this asynchronous approach. And I think this brings me to my next question. Many of our listeners are probably familiar with creating a REST API or creating a GraphQL API, and they may have used both of those previously. Does FastAPI support both of those, or does it only support one? How does that work?
For GraphQL, it doesn't support anymore. Some years ago, I think, 3 years ago, I'm not sure if it was me who deprecated and removed, but I'm sure, I think I was the one who approved the pull request. So we removed the support for native GraphQL, like the built-in, we removed it. And then we have a page on the Starlette documentation where you can see alternatives and you can integrate with it. So the way it works that FastAPI, Starlette, and other ASCII frameworks, they have a way for you to attach or bind new, also ASCII applications, so you can bind them together. And then you can, use different frameworks in your application. So for example, you can use Strawberry, which is a famous GraphQL library, and you can create a Strawberry, and then you can use, I don't know exactly how you connect Strawberry, ASCII something maybe, but then you can use Strawberry with FastAPI.
Later in the show, we're going to talk a little bit about how a person would actually write a FastAPI in Python. But before we do that, I want to spend some time talking about how FastAPI was actually implemented. I know that FastAPI uses a bunch of different frameworks, and you've mentioned some of them already, like, for example, Starlette. But I wanted to begin with something that I found really unique about FastAPI, which is that, ta-da, I get automatic API documentation. How does that actually work? Can you explain it in greater detail?
But actually, I want to go back a bit in time before that. I'm going to tell you how the idea came to exist. So there is actually an issue for that is dates like October 2018. FastAPI was created December 2018. So 2 months after this issue. So this issue was created in Starlette, where Tom Christie, the creator of Starlette, and also Uvicorn and HTTPX, MKDocs, all of those, he wanted to discuss about if and how to map the schema, the OpenAPI schema in Starlette. And then Sebastian saw that and he mentioned what he wanted for a framework, not necessarily for FastAPI, because at that point FastAPI didn't exist. And on that issue, he wrote a huge comment. It's like really huge, where you can see the ideas that FastAPI had for FastAPI. Time didn't have that name, so it didn't have any name because it didn't exist. But then Sebastian put there that he wanted the automatic documentation, he wanted validation on the input, on the output. He wanted the features that you currently see in the current FastAPI. Also, those ideas, I don't think they changed since the beginning. I think the ideas that are written on this issue still are present on the framework. And yeah, I can also send you the link so you can share with everybody with this old issue. But yeah, you asked me about how it works in great detail, the OpenAPI generation, the schema generation. So the way it works is on each FastAPI endpoint. So you have the endpoint function and you have the signature of the function, right? So the idea is that FastAPI will inspect every endpoint function and it will retrieve the signature, like gets the signature. And from the signature, it will get from the parameters and from the return statement to get those types. And it will compute the OpenAPI's JSON schema at the end. So you get each function and then you compute and then you generate the OpenAPI schema, right? One thing is that you can add some metadata and some more information. So if you know, like every endpoint function, you have the decorator, app, dot, and the method. There you can add some metadata. For example, you can add how the responses look like, because, for example, you have an HTTP exception in the body and it's a 404, I don't know. And then you can write on this responses parameter on the decorator how that looks like, because if it's in the body of the function, there is no way you can leverage type hint. So you need to write those on the decorator. So those are also being taken in consideration in the beginning of the application. Well, after computing all the information that you added on the metadata from the FastAPI class, from the API router, and from the decorator, and from the signature of the function itself, it generates this OpenAPI JSON. And then, so you have now the OpenAPI JSON. And what you want and what FastAPI does is to create for you the Swagger page or the Redoc page. Both of them are created automatically. If you don't change any settings, you have them out of the box in FastAPI.
Okay, so you mentioned it has a Swagger UI or a Redoc. To be very clear, what is Swagger UI and what is Redoc? And if I was a person who was using a FastAPI, what would I see on my screen?
Okay, so on the Swagger, well, you see a page where we document all the endpoints that FastAPI has, all the endpoints, HTTP endpoints, let's call it like that, not the WebSockets. So you'd see multiple entries describing what method it is and the path to reach that method. And then it also defines how the base URL, how it is. And then with that information, you can reach the endpoint. Also, you can check the query params, the body params, the path params that you can send to the application. And on Swagger, the nice thing is that you can interact with the application. So you can actually try the input and then try and see what the server sends back.
Yeah, thank you for that response. I have to say that's one of my favorite features of Swagger, that I can actually interact with the API directly through my web interface. I also wanted to say thank you for giving us that historical perspective before, because I think that'll help our listeners to understand a little bit more about how this FastAPI system came into existence.
Yeah.
What I want to do quickly now is to talk about the fact that FastAPI has to perform input conversion and it also has to perform output conversion. Can you tell us a little bit more about what those two things are and how that happens in FastAPI?
For example, I said that you have the parameters on the endpoint function, right? So imagine you have this item class that you define two fields. For example, name and age. I could have called it person, I know. But anyway, you have this class and then you send a JSON that instead of the age being an integer, then it's a string, potato. Then what's going to happen is that the FastAPI is going to try to instantiate this item, and then it's not going to be able. It's going to have a validation error. And then the client is going to receive a 422 processable entity, and it's going to see the response like there is an error here on this field. It is supposed to be an int, but you actually send a string potato. So, and then the client is able to understand what's wrong and then can send the right information to the server.
That was really helpful. Since you just mentioned input validation a moment ago, let's dive in and talk about that in greater detail. I'm aware of the fact that FastAPI uses Pydantic for input validation. At the very start, can you tell us what is Pydantic?
Pydantic, well, it's a company I'm working on. We have an open source project with the same name, and the package does data validation / parsing / cohesion. There is a lot of discussion about what it really does in terms of the wording, like if it's cohesion, if it's parsing, if it's validation. But I think Samuel, the creator, I think accepted already the name validation for it, what it does. So it's a way that you can be sure that the type you are writing in the classes, they're actually the types you are writing. So it's making sure that their typing is what is expected at runtime. That's pretty much what it is.
I know one of the key features of version 2.0 of Pydantic is that it's now implemented in Rust. Can you tell us a little bit more about how you made the decision to use Rust, and then perhaps talk a little bit about the benefits associated with implementing Pydantic in Rust?
I can talk a bit about it, but I don't know all the details. The decision was made before I joined the company and before I knew all the information. But yeah, I can talk a bit. So what it happened differently than V1 is that right now on V2, we build a schema. I think we call it a Pydantic schema. And then what happens is that we generate this schema, and then this schema is regenerated in Rust. So every time we instantiate a Pydantic class, then we go to the schema and then we validate our data. And that part of the schema is done in Rust.
So the benefit of using Rust is that you see a performance improvement in FastAPI. Is that correct?
Yes, it is correct. I can talk a bit more about performance there are several things that will impact the performance, but yeah, changing to V2 will increase the performance of a FastAPI application.
Okay. I also wanted to talk about some frameworks I know you have significant interest in and that you're a maintainer of. So for example, FastAPI uses something called Uvicorn and Starlette. Can you tell us a little bit more? I know we mentioned ASCII servers, but if you could fit in Uvicorn to what we've discussed and then talk about Starlette, which you mentioned before, I think it might help our listeners to understand the bigger picture of the frameworks that FastAPI uses.
So once again, the spec's called ASCII, and Uvicorn is ASCII server, which runs applications that looks like and follow the interface of ASCII. So for example, not only FastAPI, but related ASCII web frameworks. So for example, Starlette, which is a web framework as well. So FastAPI and Uvicorn can run all of them. The benefit of using Uvicorn is that it leverages the Uv loop. So it's an event loop implementation that is faster than the one provided by the standard library, so faster than the async.io. And it also uses HTTP tools, which is a HTTP parsing library that is a binding for a C library right now I forgot the name, but it's the same one that's Node.js uses it. So Node uses a binding as well, and HTTP tools it's a binding for the same C library. And yeah, Uvicorn is just the web server. And Starlette. Oh, there are also other web servers that are in this world, but Uvicorn is by far the most famous one. There is one called Hypercorn. I don't know how Phil pronounces it, the creator, but it's also a very good implementation. The difference between those two servers is that one uses streams. So in Python, you have, for creating web servers, you have protocol, and the other one is with streaming. So Hypercorn is with streams. So it's more higher level. So that's why Hypercorn has, for example, Trio support. Trio is another async library that is very famous that uses structured, how do you call it? Structured programming? No, structured concurrence. Structured concurrency. I think that's the name. But then, Uvicorn uses protocols, which is a lower level. And then that's why it's also one of the reasons that is faster than Hypercorn. And also you asked me about Starlette, right? Starlette is a web framework that provides all the web capabilities for FastAPI. So everything that is about that, the first step to go back to Uvicorn. So the way it happens is like the client sends a request, Uvicorn parses the request, sends to the web framework, FastAPI. So everything in the middle here it goes back to Starlette. So it goes client, Uvicorn, FastAPI. So it's instead of directly to FastAPI, there is Starlette in the middle. It's just that FastAPI is actually, it inherits from Starlette. So it just gets all the capabilities that Starlette has to offer.
That sequence of events was really helpful. I appreciate you sharing that. I wanted to ask one quick clarifying question. You mentioned a client that might be connecting to a FastAPI. I know that FastAPIs are created in Python, but is there a restriction in terms of the programming language that we use in order to interact with a running FastAPI?
You mean the client?
Yeah.
No, you can use any HTTP client.
Okay.
In any language.
So the last thing that I wanted to talk about when it comes to Starlette is that I often hear people refer to Starlette as a web micro framework. What does it mean if it is a micro framework?
I think the idea of being a micro is that you can use any part of Starlette independently. You don't necessarily need to use the Starlette class. You can use, for example, the response by itself, the response class by itself, because the response class is already a web framework, application. So you can just use that part. You don't need to use the whole Starlette. You can use pieces of Starlette. I think that's the idea.
I know that many of our listeners, when they hear the phrase web framework, are probably going to think of, in the context of Python, things like Django or Flask. Can you comment briefly, how are Django and Flask connected to or different from FastAPI?
So I know that, for example, Flask in the beginning, Sebastian tried to, I think he also created one package that was Flask something, or tried to improve that. So the idea was not to create a FastAPI in the beginning, but to improve the current applications that like web frameworks that existed at the time. If I see Flask in the point of view as a user, it's just very similar to develop compared to FastAPI in the terms that you use also a decorator, you define what method you have. Also, lately, I think 2 years ago, Flask created the decorators that you can use the HTTP method. So before you couldn't, like for example, app.get, app.put. You didn't have that before. And I think, well, I like to believe, but it seems obvious because of how popular FastAPI got. But I hope this is correct, that was inspired by FastAPI. Because before you had only app.root and then you had to put the method there. But in any case, I believe it's very similar to develop with Flask and FastAPI. In terms of creating the application itself, I think the differences are subtle, but they matter on the usability of the framework, like creating the application itself. Like you have the type hints on FastAPI, you have the automatic documentation, but you can also have, nowadays, you have some similar packages that you can use Flask with and have those capabilities, but it's not native. And what I noticed is that having those things, those features natively makes a huge difference from the user, because then you don't need to think much about how to get those things working. It's just out of the box.
Can you give a concrete example of something that you would choose to use FastAPI to build, and then in contrast, give an example of something where maybe you would instead prefer to use Django or Flask?
Oh, I don't have good news here.
Okay.
I don't think I would prefer use the alternatives in any case, but I would know, like, for example, I know that you could use Django to really nicely serve static web for applications. I know that use case. Also, I know that people like that the Django ORM is in the same, like it's included on the Django thing. So you have the ORM, you have the how to serve files, you have the Django CSM or something like that. You have a lot of Django things that are, again, native from the framework that people really like. But I am very used to the FastAPI world, so I would just use FastAPI for pretty much any use case.
Am I right in understanding that I would primarily use FastAPI for creating a REST API, but if I were to build a full web application, like with a graphical interface, then that might be a case in which I would pick Django. Is that a fair statement?
I think for me, no. But I can see people agreeing with that because, again, it's out of the box on Django. You don't need to think much about it. Like, you have even tutorials about it. You have a lot of information during the years about this specific subject, like how to do that specific thing that you are asking me. But on FastAPI, you can also serve static files just fine. You have even a static files class that you can serve what you intend to.
Okay, that makes sense. Thanks so much for that clarification. I really appreciate it. I want to now turn our attention to some issues connected to security. two keywords that often come up in the context of API security are authentication and authorization. And so my question is, does FastAPI support both authentication and authorization?
So FastAPI does not handle that for you. So you need to implement the layer yourself. What it does is you can define a way for how to interpret some data that comes from the request. So for example, you have HTTP basic class, which it's used for FastAPI to get the authorization header and then get the username and the password, and it provides that to your endpoint. So you use that class just to kind of parse that data for you, but it does not handle that for you. What I mean handle is that you don't have a logic to verify that the user exists in the database, that's the correct password. That's something you'd have to implement yourself. There are some libraries that are available for that. I honestly haven't used any, but I have a friend called Frankie and some numbers that has FastAPI users. So if you Google FastAPI users, you're going to find it's a 4K GitHub stars project. I don't know how many users, how many downloads it gets a day, but he's a very good developer. So this is one possibility as an auth library to use with FastAPI.
Okay, so it sounds like it's not that FastAPI natively supports authentication and authorization, but that there are packages that you can add on in order to make that work. Is that the right way to think about it?
I would say it's the same idea as Flask. On Flask, you also don't have a way to natively do this logic. Like you have to implement that yourself, or you have to use any third-party library to do that for you.
Okay, and we'll make sure to link to the framework that you mentioned a moment ago so that our listeners can check it out.
Yeah. One library that I always use is auth-lib.
Yeah, that's a good one to bring up. Can you explain it in a little bit of greater detail?
It helps to do the auth logic on your application. It's just very famous. There's one thing that I don't like that they're doing for years, and then I complain and then they don't reply to me, is that they use this config class from Starlette, to receive two environment variables, secrets, I think, or something like that. I use auth-lib to integrate with GitHub. I think that's my use case, or that was my use case. And then they use the config class from Starlette, but that's a feature that no one uses it, and it prevents me from deprecating it. So, I'm saying everybody, I don't know who uses it, to be completely fair on this, but it prevents me from acting on it because this library uses it and I really use the library. So,
yeah, I see what you're saying. I think it's in part making your job as a maintainer perhaps a little bit more difficult.
Exactly.
So what I want to do now is talk a little bit about how a programmer would actually design and implement and test their own FastAPI. Since we've already covered some of the details about how FastAPI is implemented, I think we're ready to launch into the next stage of our show. So can we talk a little bit? You mentioned before, I've got to write a function that represents an endpoint. I have to have type annotations for that. And I think many of our listeners will be comfortable with that process. My next question is, how do I actually deploy a FastAPI?
So I'm going to comment on that, but I want for our listeners to go to the FastAPI documentation on this, because there is a very good page. If you go to FastAPI, you see deployments. FastAPI, Sebastian dedicated good time on writing those docs, and it explains in good detail about what are your options and how to do the deployment. There are some ways that people do the deployment. Like, for example, there are people that deploy only with Uvicorn. I know that one of the maintainers of Uvicorn, like the one that was previous to me, now he's very not active, but he used only Uvicorn with just a single process. And then he said to me, yeah, it's been running for a month. No problem. 100 of requests. It's all fine. He said it to me when we were drinking a beer. So I was like, oh, that's good. And then there is also recommendation on the Uvicorn documentation, for example, to use Uvicorn with Junicorn. And Junicorn is also a web server implementation, more focused on the UASG world, but they also have a process manager. So the idea is that you'd have your Uvicorn workers, your Uvicorn processes being managed by Junicorn. So you can also deploy with Junicorn and Uvicorn. And what you will do is that every time a Uvicorn process dies, it's going to restart that worker, so that process. And then you're going to always have that number of workers running. So for example, I create a Junicorn Uvicorn server with 4 Uvicorn workers. And then if one dies, Unicorn will automatically restart a new worker. So you're always going to have 4 workers during the whole lifetime of the application.
So this combined approach that you're describing now sounds like it would be beneficial because it would make your system more reliable. Is that the right way to understand it?
Yeah, that's correct. But also nowadays, people are using Kubernetes and very fancy technologies. So I would say that on that world, it is easy and more recommended to use Uvicorn with a single process, because then you have each pod will have one process, which is the Uvicorn process. And then that's going to be your unit in the system. And you don't want to complexify that part with Unicorn in the middle, because then you're going to have the process one, it's going to be Unicorn, and then you're going to have multiple Uvicorn workers. It gets too complex for the need.
I see what you're saying. I wanted to also talk a little bit about what a developer would do when they're testing a FastAPI. One of the things that I've done is I spin up a local host server. Once I have that local host server running, can I use things like unit test or PyTest in order to test my FastAPI?
Well, we have a test client in Starlette and FastAPI that you can use to test your endpoints. The way it does internally is that it simulates how the networking happens, but it does not really create, like you are running everything in Python there. That's just how it happens. So that would be the way to test your FastAPI application. But also you have the test client from Starlette, and you also have the test client, the client from HTTPX, which is async client. And that's the recommended one.
Is there a difference between using PyTest to test a regular Python function or method in a program versus testing something that comes from FastAPI?
I'm not sure if I understand the question.
So the idea is many of our listeners are probably familiar with writing a function in Python and then writing a PyTest test case, or maybe a property-based test with hypothesis. And I guess my question is, how would the process for testing a FastAPI be different from what they're normally used to for something that it's just a regular Python function or method?
So the way I believe things should be when you are developing a FastAPI application or any web application is that most of your tests are going to look very similar, on which you have your entry point, which would be calling the endpoint, and you're going to always test again an expected output. So we're going to call this endpoint called /potato, and you expect, 3 potatoes to be back. And then the idea that I have on how you should test this, and I don't know if you'd want to call it unit integration. I don't care. But the idea is that you want to test something, the input, and against an expected output. Doing this, trying to be not trying to test all the functions that are in the middle, you open space for changing the internals without breaking the API. And also using your efforts, your energy to test this part of the code. So my idea is you have your tests, and most of them are focused on the input and output. And then you are free to change and refactor the code as you want. But also, if you have some important logic that you want to really unit test, for example, there is something really important on the system that you really need to test, then you are free to create some unit tests. But the way I believe is that most of the tests on a web framework should be input, output, that's it.
The strategy you're suggesting makes a lot of sense. If there are listeners of our episode who want to learn more about designing and testing APIs, we'll link them to episode 387 and episode 542 in order to get more information. Now, one of the things that I would love to do in the next phase of our show is talk with you a little bit about your experiences of maintaining packages like Starlette. Obviously, you have to think carefully about how to test your own code in Starlette, and you have to think carefully about how you document and you lint all of the systems that you're building. Can you share with our listeners some of your philosophies and strategies when it comes to designing and implementing maybe Starlette or Uvicorn or FastAPI?
So first, I think I follow the philosophy of each project specifically. So for example, Starlette and Uvicorn are under the Encode organization, which was created by Tom, and I try to follow his philosophy. What I mean by this is that I always try, most of the time, to, if a feature is not needed on the package, and it can be a third-party package, then let's go for it first. Let's see how is the desire for that feature on the world. And then if it gets really a lot of attention, then we can merge the feature into the library itself. So for example, you can create a middleware in a third-party package, and then if that gets a lot of users, then you can go back to Starlette and then you create a pull request against it, and then you have that merge. So this is the first thing. But for example, Pydantic is more permissive on the amount of pull requests. So for example, we create these Pydantic extra types, which accepts a lot of types, accepts a lot of new types to be added on the library. So it really depends on the project.
One of the things I noticed on the FastAPI documentation is that it specifically says that the code base is 100% type annotated, and actually its test suite has 100% test coverage. Why might that be a goal for the people who are maintaining the FastAPI system or other open source frameworks?
I think it proves something. At least I believe that, well, I am a strong believer of the number 100. Anything that is less than that, I do not think it's a good number. I've heard many times on a lot of companies, people saying, oh, don't worry, we have a pretty high coverage. We have 85%. But then you start looking and actually the most important things are not tested. So it really doesn't matter. And I think that what I really believe is the 100% clean coverage, where you aim for the 100%, you're going to do the 100%, but you're going to proactively choose when to not have something tested. And the idea is that when you write the ignores on those lines that you don't want to test, well, you're doing it that actively. So you are making sure that you don't want to test that. So that just makes sure that the library is in a better state than it could be.
One of the things that I've learned about FastAPI is that it's something that really enhances developer productivity. I find it incredibly easy to make an API and then get it up and running and have it deployed. What were some of the strategies that the FastAPI team developed in order to ensure that actually creating an API with FastAPI was fun and it was something that enhanced developer productivity?
You mean strategy?
Well, you might not have necessarily had a strategy per se, but in your experience, what is it about FastAPI that makes it something that enhances developer productivity and makes it so easy to get up and running and ship an API?
I think it's because people care about developer experience. And when I say people, I mean the maintainers of the libraries that are related. So I think Sebastian cares a lot about dev experience. I think Samuel as well. I think I do as well. So I think putting the maintainers of those related packages in like how you see them, if you work with them, you see that like they are bothered if something takes one more second to do or one more step. They're just bothered about that thing. So everything is around this philosophy of doing things that maybe faster, but have a better developer experience.
Can you give a concrete example of what an enhanced developer productivity experience would look like?
Yeah. So for example, FastAPI has the parameters, which you have the types on it. You need to have the types on it. Otherwise, you're going to have an error. So you put the right type and you are sure that's the right information you're going to receive from the request. And then you have automatic like out completion on your IDE. So that's one thing that saves a lot of time because, well, you have out completion. So you don't need to think about what to write there.
Yeah, that's a really good point. And I've had exactly that experience myself as well. I wanted to also ask you a question about your experiences. You've had a lot of years invested in things like Starlette and Uvicorn and FastAPI. Have there been some aha moments or some lessons that you can pass along to other developers? Like, what was something that you learned that was somewhat unexpected?
I learned that sometimes you need to be patient. You need to wait and see if something is really worth it feature-wise. Sometimes getting too excited, it's a problem. People are actually more unhappy about things that change than things that continue the same, even if they are not the best thing. So when trying to improve something, you need to be careful to not break other people's APIs and not break the current way of the way they were doing things.
Wow, that's an awesome insight. Is there something that we haven't talked about in the context of FastAPI that you think we should discuss in greater detail?
No, I think we talked plenty. Yeah, no, it's good.
All right. So in our episode, we've covered a lot of the key concepts associated with APIs and FastAPIs Then we dove into how FastAPI was actually implemented, and then we've learned some strategies for actually creating, testing, and deploying a FastAPI. Thank you for sharing all of those insights. I really appreciate it.
Thank you for having me here.
As a conclusion to our show, do you have a call to action for our listeners in case they want to learn more about FastAPI or get started with this framework?
Yeah, read the docs. The docs are amazing. Go for it.
All right. I have to echo that comment. The docs are absolutely amazing. We'll make sure to link to those in the show. So let me say again, thank you. This has really been an awesome conversation. I hope that you have enjoyed the conversation. If you're a listener, Marcelo, thank you for being here on Software Engineering Radio.
Thank you very much. It was great.
Okay, this is Gregory Kapfhammer, and I'm signing off for Software Engineering Radio. Goodbye, everyone.
Bye-bye.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.